All right, guys, this is special right triangles. And I know what you're thinking. Aren't all right triangles special? And the answer is yeah, they really are. But these are the most special ones. We got a lot to go through. We're going to talk about the patterns here. This is very pattern-based. Some people are going to be really good at recognizing and applying patterns. And some people are not going to be as strong, and that's okay. It just means you're going to have to maybe work a little harder and find other ways to get answers. Before I tell you what the pattern is, let's go through a few of these triangles and see if we can figure out the pattern. It says find the missing sides. So if I just gave you this question and you didn't know anything other than Pythagorean theorem, you would do Pythagorean theorem. What do these sides reduce to, right? Divide by 7, you get 1. Divide by 7, you get 1. We talked about how to do Pythagorean theorem, reduce the numbers if possible. So we're doing 1 squared plus 1 squared here, right? The square root of 1 squared plus 1 squared equals the square root of 2. So on the small version of this triangle, we have a square root of 2. And maybe I'll draw a separate triangle here so you can kind of see it. We're making a smaller, similar triangle where we divide by 7, divide by 7. We did Pythagorean theorem. That hypotenuse is going to be the square root of 2. Well, if we divided by 7 to get there, we're going to multiply by 7 to get the original size. So that one would be 7 root 2. Let's look at the second one here. What's the GCF, right? So we have 5 and 10. We can divide those by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. And let's do Pythagorean theorem on this small triangle. We would know that hypotenuse squared minus the leg squared, right? If you have the hypotenuse, you need to subtract. So we have 4 minus 1 is 3. This would be the square root of 3. So this side would be represented by the square root of 3. But we divided by 5 to get there, so we need to multiply by 5 to go back home. So this would be 5 root 3. I'm going to go a little bit quicker on the rest of these, but this is 16 and 16. We actually have the same situation on number 1, right? Divide by 16, you get 1 and 1. Well, when it's 1 and 1, what's going to be the hypotenuse? It's going to be the square root of 2. So 16, we divided by 16 to make the small one. We're going to multiply by 16 to go back to the big one. Okay. How about over here? We got another right triangle. I'm going to make a smaller version. What's the GCF? 12 and 6 root 3. We can divide by 6. That would give us the square root of 3. 12 divided by 6 would give us 2. So let's do Pythagorean theorem on that. Since we know that 2 is the biggest one, we're going to do the square root of the hypotenuse squared minus the leg squared. And that would be the square root of 4 minus 3, which is the square root of 1, which is 1. So that is, so that last side is going to be 1, but we need to make it 6 times bigger. 6 times 1 is 6. Okay. Keep the ball rolling. Here's another Pythagorean theorem. No common factor here, so we're just going to, so just straight Pythagorean theorem. X squared plus x squared equals 8 squared. Adding is, guys, we talked about adding before, but adding hasn't changed since you were in kindergarten, right? In kindergarten, you added cows and bananas and things like that. If you have 1 banana and your friend has 1 banana, how many bananas do you have together? You have 2 bananas, right? Adding has never changed. You can only add like terms. But if I have 1 banana and my friend has 1 apple, would you say you have 2 bananas? No. But are these like terms? X squared and x squared? Yeah. 1x squared plus 1x squared. How many x squareds do I have? I have 2x squareds. And then 8 squared is 64. Divide by 2. Take the square root. So we talked, this is stuff we did last time, but this would be the square root of 16 times the square root of 2, which is 4 root 2. The square root of 16 is whole number 4. So this is 4 root 2 and 4 root 2. Okay. Over here we have 4 and 4 root 3, so I'm going to reduce those by a factor of 4. 1 and root 3, we need the hypotenuse, so that's going to be the square root of 1 squared plus root 3 squared. Why did I add this time? Well, the hypotenuse has to be bigger. So if I'm looking for the hypotenuse, I'm going to add with my Pythagorean theorem. That's going to be the square root of 1 plus 3, which is the square root of 4, which is 2. So we divided by 4 to get there. We're going to multiply by 4 to go back home. And so those are the ones I wanted us to do by hand to kind of see what the pattern is. Let's look at these. Let's look at these. Let's look at all the 45, 45, 90 triangles first. Well, this one was 7. Oh, sorry, I jumped the gun. What kind of triangle is this? Well, if those are both 7, aren't those two sides equal? Which means these two angles would have to be equal. We call this a 45, 45, 90 triangle. Or because of those two 7s being equal, we know that this is an isosceles right triangle. So we can call it either thing. Isosceles right triangle, 45, 45, 90, same idea. But that is 7, 7, 7 root 2. How about this one? This one's also an isosceles right triangle, right? Those are both 16. 16, 16, 16 root 2. So 7, 7, 7 root 2. 16, 16, 16 root 2. What's going on there? It might be kind of hard to see. But this is, let's write it out. We have 7, 7, 7 root 2. We have 16, 16, 16 root 2. Does this one fit the same pattern, right? These two sides are equal, so this is another 45, 45, 90. 7, 7, 7 root 2. 16, 16, 16 root 2. Well, this one is 4 root 2 and 4 root 2. What would that make the hypotenuse? Would it make it 8? Well, 4 root 2, but I need to put another root 2 on it, right? Because this is like 7, 7, 7 root 2, 16, 16, 16 root 2, 4 root 2, 4 root 2, 4 root 2, root 2, which is 4 times 2, which is 8. So yes, this one fit the pattern. And so something I need you to understand is that every single 45, 45, 90 is going to reduce to the same thing. Look at these 45, 45, 90s. What did this reduce to? 1, 1 root 2. 1, 1 root 2. I didn't actually do it, but this one also reduces to 1, 1 root 2. I promise. Right? 4 root 2, 4 root 2, 4 root 2, root 2. 1, 1 root 2. Every single one of them reduces to this. It's kind of like when we had our right triangles. Remember we talked about triples last time? We had a 3, 4, 5. And we talked about how 6, 8, 10 is a part of that family. Every single multiple of 3, 4, 5 reduce back to 3, 4, 5. Right? 6, 8, 10 reduces back to 3, 4, 5. It has a GCF of 2, and it's part of the 3, 4, 5 family. Every single isosceles right triangle reduces, or can be you can pull a GCF out and create 1, 1 root 2. It has to be that way. So what are the rules here? The rules are 1, 1 root 2. If you know the leg, right? If we know how big this side is, how do we get the hypotenuse? How do you go from the number 1 to the number root 2? Well, you multiply by the square root of 2. So if you have a leg, you take the leg and you multiply it by the square root of 2, and that equals the hypotenuse. Okay, that's not so bad. How do you go backwards? If this is root 2, how do you undo that? So to make root 2, you do times root 2. So going forward, right, we did times root 2. Well, how would we undo this? What if we wanted to solve this for the leg? Right? So like if we know that this equals root 2, could we divide by root 2 on both sides and know that the hypotenuse divided by root 2 equals the leg? Yes. Yes. So if you have the leg, you're going to get bigger. In order to get bigger, you're going to multiply by root 2. If you have the hypotenuse, you have to get smaller. To get smaller, you have to divide by root 2. Okay, how about the next set of triangles? Let's see what we can figure out over there. So this triangle was 5 root 3, 10. 6 root 3, 12. 4 root 3, 8. What is going on? What would this one be? 6 and 12. Think real hard about what we just saw. This would be 6 root 3. 20 root 3 and 20. See if you can think about what it could be. Comes out to 40. What's the pattern? So just like 45, 45, 90s, there's a pattern here. When we reduced these triangles, what did they all reduce to? 1, 2, root 3. 1, 2, root 3. Yeah, what does this one reduce to? 1, 2, and root 3. So that's what they all become, guys. Let's look at those numbers real quick. 1, root 3, and 2. What is the biggest number there? This is the biggest one, right? This is approximately 1.7. You need to understand, 2 is bigger than root 3. A lot of people get confused, and then they think, oh, it's root 3, and they think root 3 is bigger, and it feels weird, right? Like 6 times root 3 and 6 times 2. Which one's bigger? 6 times 2 is bigger, right? 12 is bigger than 6 times root 3. That's stuff that you really need to understand as you work on this. So knowing that, the smallest side is always going to be across from the 30-degree angle. The biggest side is always going to be across from the 90, the hypotenuse. And the middle side is always going to be across from the 60. So in this picture, it is very important where you put the numbers. The smallest number has to be across from the smallest angle. The smallest side has to be across from the 30. The middle side has to be across from the 60, and the biggest side has to be the hypotenuse. So sometimes the triangle's twisted and turned and flipped. You got to make sure you're getting the correct numbers in the correct spots. So that is 1, root 3, and 2. Some people get confused, which triangle is root 2, which triangle is 2. That's a common issue. Let's say you forget. Make a right triangle. What if you thought it was 1, 1, 2? What if this is what you thought? Is that even a triangle? What is 1 plus 1? That is 2. Is 2 greater than 2? No, that doesn't even make a triangle. There's not enough room to even be a triangle there. You can't be 1, 1, 2. It doesn't work. So the 45, 45, 90 is not 1, 1, 2. It is 1, 1, root 2. And the square root of 2 is not a whole number. The square root of 2 is about 1.4. The square root of 3 is not a whole number. That's about 1.7. So don't get those mixed up. This pattern is 1, square root of 3, and 2. So on this one, there's no more situations. There are 3 starting spots. What if you start with the short leg? So like going back up to the ones that we had before. Never mind. I'm just going to tell the rules. What would you do to the short leg to get the long leg? And it's called the long leg. It's not the longest side, but it is the longest leg. There are 2 legs. So this is the short leg. This is the long leg. I write SL for short leg, LL for long leg, and then this is the hypotenuse. The hypotenuse is the biggest overall side, but the long leg is the longer of the 2 legs. Over here, there is no long leg because they're the same size. So I just said L for leg. They're the same size. All right, so how do you do this? It might be helpful to see like an example. So let's go down here real quick. What if I'm on this triangle? If I know that this is a 30, 60, 90, it's helpful to draw the base triangle over here. They put the 30 at the top, so I'm going to put the 30 at the top. What has to go across from the 30? The smallest one, 1. The biggest side is the hypotenuse, and the middle side is the long leg. It's root 3. Well, if this short leg is 1, how do you go from 1 to root 3? Well, you have to multiply by the square root of 3. So this side would be 6 root 3. How do you go from the short leg to the hypotenuse? Well, the hypotenuse is twice the size. So if you have the short leg, you can make the other 2 sides through multiplication. The long leg is times root 3, and the hypotenuse is times 2. So if I have the short leg, I'm going to take the short leg, and I'm going to multiply it by the square root of 3 to get the long leg. And I'm going to take the short leg, and I'm going to multiply it by 2 to get the hypotenuse. All right, well, what if I start with a different piece? This one here is a different piece. Let's take a look. I'm going to redraw my triangle. Oh, no, look here. This one, the 30 is at the top. Pay attention. Oh, gosh, this could really mess this up, but the 30 is in the bottom right. So do I put the 1 down here? No. The smallest side is across from the 30. There's my 1. There's my hypotenuse, and there's my long leg. This would be my 60 on this triangle, the 30 and the 60 flipped. You have to pay attention to where the angles are. Okay, well, what do we have on this one? We have the hypotenuse. What is associated with the hypotenuse? The number 2. It's times 2. How do we make the hypotenuse? We had to do 6 times 2 to make the hypotenuse. So how do we unmake that? How do you undo that? If it is the short leg times 2 to equal the hypotenuse, couldn't I divide both sides by 2? Isn't the hypotenuse divided by 2 equal to the short leg? Yes. So to go backwards, you must divide by 2. That is 5 root 2. Once you know the short leg, you're just going forwards again. That's times root 3, right? 1 to root 3 is times root 3. So what is 5 root 2 times root 3? Well, that is going to be 5 root 6. So those are your 2 missing sides. Okay, so what are those rules we just said? If you have the long leg, we just did the hypotenuse one. If you have the hypotenuse, your first job is to divide by 2 and get the short leg. And then once you have the short leg, just like up here, how do you get the long leg? You multiply the short leg times root 3. And that gets you the long leg. Oh, I'm loving it. I'm loving it. All right, there's one more situation. We saved the best for last. This is a toughie. Well, at least the 30 is back where it belongs up top. Yeah. 30 is up top. That means that the 1 is at the bottom. This 60 degrees, so this would be the square root of 3, and the hypotenuse would be my 2. What is associated, so this is my 60, what goes with the 60? That is the root 3 side, right? So how do you go forwards? How did we do that? Like when we had this one, how did we go from short leg to long leg? We did times the square root of 3. That's how you went from short leg to long leg. So how do we undo that? Well, let's see. If the short leg times the square root of 3 equals the long leg, could I divide both sides by the square root of 3? Yeah. That means that the long leg divided by the square root of 3 equals the short leg. So if we take the 12 and we divide by the square root of 3, we will have the short leg. Well, that's a little bit more work. 12 divided by the square root of 3 is, well, I'll write it out. But you need to start getting to the point where you can do this in your head, but you're multiplying it by root 3 over root 3. And what happens is you get radical 3 on top, and you get whole number 3 on bottom. Root 3 times root 3 is 3. And then you got to clean that up. 12 divided by 3, that is 4 root 3. So this side would be 4 root 3. And then once you have the short leg, how do you get the hypotenuse? You do times 2. That would be 8 root 3. So in this triangle, the missing sides are 8 root 3 and 4 root 3. That's some good stuff right there. So if you have the long leg, you have to take the long leg and divide it by the square root of 3 to get the short leg. Once you have the short leg, you need to multiply it by 2 to get the hypotenuse. I'll separate those out a little bit. Those are your 5 rules. That's a little bit more work there. Let's do a couple of these 45, 45, 90s because we didn't really touch those. So let's remember the rules. We talked about the rules. Here we have a leg. We take the leg and we multiply it by the square root of 2 to get the hypotenuse. So this hypotenuse would just be 10 times the square root of 2. And then the other leg would just be the same size. Here we have a hypotenuse. How do you do that? Well, if we look at the rule, it's the hypotenuse divided by the square root of 2 equals the leg. So for this problem, it'd be 12 divided by the square root of 2. Oh, sorry, not 12. 12 root 3 divided by the square root of 2 equals the leg. We got to clean that up. That would be 12 root 3 over root 2. So we're going to multiply it by root 2 over root 2. That is 12 root 6 over 2, which is 6 root 6. 12 divided by 2 is 6. Over here, we got another 45, 45, 90. We know that if we have the leg, we multiply it by the square root of 2 to get the hypotenuse. So this would be 4 root 6 times root 2. That is going to be 4 square root 12. Well, we got to break down 12. If the radical is not fully simplified, you're not done. This is this is 4 times the square root of 4 times the square root of 3, right? Isn't root 12 the same as root 4 times root 3? Yep. Well, that's just 4 times 2 times root 3. That is 8 root 3. So the hypotenuse is 8 root 3. The other leg would be 4 root 6. Here we got 3 more. They get a little trickier maybe. 30, 60, 90. Here's my 60. So where is this? It helps to draw the triangle sometimes. Here's the 30. The short leg is across from the 30. The long leg is across from the 60. And the hypotenuse is your biggest side. So this is the long leg. Remember, you do the long leg divided by the square root of 3, right? If it has the root 3 in it, we have to divide by the square root of 3 to equal the short leg. So this would be 4 root 10 divided by the square root of 3. This is the process. We've talked about this. I hope we're getting good. That would be 4 root 30 over 3. So this side would be 4 root 30 over 3. Well, how do you then get the long leg? Well, remember that, we got the short leg. How do you then get the hypotenuse? The hypotenuse equals the short leg times 2. Well, 4 root 30 times 2 would be 8 root 30 over 3. And those would be our answers. Couple of common mistakes people make is they say the answer is 8 root 30 over 6. What they're doing is times 2 on top and bottom. That would get you 8 on top and 6 on bottom. But we talked about this last time. What is 2 divided by 2? That's the number 1. 8 over 6, what does that reduce to? It reduces right back to 4 over 3. You didn't change the number at all. You didn't multiply by 2. Guys, if you do this, that is not times 2. That is times 1. And times 1 doesn't change the number. If you want to get a number that's twice as big, you have to multiply the top by 2. If you double the top, you double the number. If you double the bottom, you're cutting the number in half. And if you double the top and double the bottom, you're not doing anything. It's the same number. So please keep that in mind. Please, we got to be very good at multiplying these numbers. All right, let's go over here. So this is wrong. We have another 30, 60, 90. Let's just let's draw a new reference triangle. Our 30 is down here. Woo! That means this is 1, root 3, and 2. The hypotenuse is the part that we have. We know that the hypotenuse divided by 2 equals the short leg. So I'm going to take 3 root 2 and divide it by 2, and there's nothing I can do with that. So that's the end result. That's the short leg. And then what do I do to the short leg to get the hypotenuse? We know that the short leg times 2 equals the hypotenuse. Wait, what am I talking about? We have the hypotenuse. We just came from that. We want the long leg. The long leg times the square root of 3 equals... Now I'm a little bit all over the place. Sorry. The short leg... Let's fix this. The short leg times the square root of 3 equals the long leg. Okay, we're back on track. We're back on track. This is the short leg. We need the long leg. We need to multiply this number by the square root of 3. Well, that would be 3 root 2 times the square root of 3 would get me 3 root 6 over 2. Boom. Down here, we have the hypotenuse of a 45, 45, 90. That's 1 root 2. To get the leg, we do the hypotenuse divided by the square root of 2 to get the leg, right? If we have the hypotenuse, we have to divide by the square root of 2. So that would be 21 root 8 divided by the square root of 2. I would reduce that. That's radical 8 radical 2. That becomes 21 root 4. Root 8 divided by root 2 is root 4. Well, that's just 21 times 2, which is 42. So these sides would be 42. There's more than one way to do this. You could have broken down the root 8 and said root 4 times root 2. And then you'd have 21 times 2 times root 2, which is 42 root 2. And if your hypotenuse is 42 root 2, you would have done 42 root 2 divided by root 2. Those cancel out, and you get 42 again. There's lots of ways to get to Walmart. Some ways are quicker than others, but there's lots of ways to do it. As long as you're executing correctly, you're going to be okay. Here's some ways that we're going to use this throughout the year. You might see rectangles. Rectangles have right angles. If you just know two sides, that's just normal Pythagorean theorem, my friends. So we have a right triangle. I'm going to draw a similar one. Divide by 6, this would be 3. Divide by 6, this would be 5. Is this a 3, 4, 5? Is this going to be 4? No. Guys, 3, 4, 5. That's got to be the hypotenuse. If it's a 5, 12, 13, this has to be the hypotenuse. The biggest number must be your hypotenuse, or it's not one of our triples from last time. So yes, I see the 3 and the 5, but this can't be 4. The hypotenuse can't be smaller. So we're going to have to do Pythagorean theorem. It's the square root of 3 squared plus 5 squared, which is 9 plus 25. That's the square root of 34. But we multiply by 6 to get 6 root 34. Right? We divided by 6 to get the smaller one. We have to multiply by 6 to get the bigger one. So that was just normal Pythagorean theorem. That was not the new stuff. How about if it's a perimeter of a square? Well, on a square, all four sides are equal and the angles are 90. So what we have is a 45, 45, 90. And we know that a 45, 45, 90 is 1, 1 root 2. So what do I do if I have the hypotenuse? I have the root 2. How do I get rid of the root 2? You do the hypotenuse divided by the square root of 2 to get the leg. So this would be 3 root 3 divided by root 2. I need to clean that up, so I'm going to multiply the top and bottom by root 2. That would get me 3 root 6 over 2. But they didn't ask for one side, they asked for the perimeter. So hold up, we got to do 3 root 6 over 2 times 4 of them. There's a lot of ways to think about this, but what's 4 divided by 2? 4 divided by 2 is 2. 2 times 3 is 6. So this is 6 root 6. So if you see a square and you draw a diagonal through a square, you need to know those are going to be 45, 45, 90 triangles. They are isosceles right triangles. They're going to be 45, 45, 90s. All right, how about this last one? We have an equilateral triangle. That means every side is the same length, 16 and 16 for those two sides. It's asking for the area. Area of a triangle is 1/2 times the base times the height. That's a formula what we've known for a little while. We don't have a height. My friend, the Snoop D-O-double-G, has a song about this. He talks about how if you need to get area, you need a height. So what does he do? He drops it like it's high, drops it like it's high, drop it like it's high, drop it like it's high. Yeah, we got to drop those heights. Guys, we're going to be dropping heights all semester. Guys, if you don't have a right triangle, you better make a right triangle. And you make right triangles by dropping heights. And this is an equilateral triangle. So when we drop that right triangle, you know, these corners are all 60. Cuts it in half. Now it's 30. Ooh, now it's a 30, 60, 90. Also, if you remember, if it's an equilateral triangle and you drop a height, it cuts the side in half. So even without knowing your 30, 60, 90 rules, you should know that that's cut in half. But let's look at our 30, 60, 90 rules. We have a 30 up here. This would be 1 root 3 and 2. So which part do we know? We know the hypotenuse. So we know that the hypotenuse divided by 2 equals the short leg. So that would be 16 divided by 2, which is 8. Well, we already had that. But we can confirm it there. Once we know that, how do we get the long leg? We know that the short leg times the square root of 3 equals the long leg. So this is going to be 8 times the square root of 3. So the area would equal 1/2 times the base would be 16. We're talking about the base of the original triangle, 16, times the height we just got. Drop it like it's height. Drop it like it's height. 8 root 3. So the area would equal 1/2 of 16. That's 8. 8 times 8 is 64 root 3. All right, guys. Hopefully that made sense. You need to know how to use these 30, 60, 90s, these 45, 45, 90s. It is muy importante. Got to know how to do it. Good luck. Have fun.